In this video, we are going to start our work with graphing quadratic functions. The first box here reminds us of what a quadratic function in standard form will look like. F of x equals ax squared plus bx plus c. So this is called the quadratic function in standard form. Okay, input variable is x. The function notation f of x here is taking the place of the y, right? That's our function notation. So this is standard form. So in the second box, we've got what we call the parent function of the quadratic function because it's our most basic quadratic function that we can have. This is f of x equals x squared. So notice a is 1, the leading coefficient is 1, and then b and c are both 0. So we call that the parent function. And on the far right, you have a table of values that can help you graph this function. So notice what the function does. It takes the input, x, and it squares it for the y, for the output. So when x is -3, when we square that, we will get a y value of 9. So -3, 9 will be on our parabola. And unfortunately, it's up here somewhere, okay, in our graph. -2, when x is -2, when we square -2, we get a y value of 4. So the order pair -2, 4 is on our parabola. -1, square that, our y value is 1. So -1, 1 is on our graph, which is on our parabola graph. 0 squared is 0. So our parabola goes through the origin. 1 squared is 1. So 1, 1 is on the graph. 2 squared is 4. So 2, 4 is on the graph. 3 squared is 9, so 3, 9 is on the graph again. And so this shape is called a parabola, as you know. 0, 0, this lower point right here, that's called the vertex. And then I want you to notice that the parabola has some symmetry. The two halves look the same, don't they? That in our example, the y-axis is acting as the vertical line that splits the parabola into two equal halves, right? And so we give that vertical line a name and we call that the axis of symmetry. So in our parent function, it happens to be the y-axis, but when we move the parabola around the graphs, you're gonna get different vertical line equations, right? So you'll see that in the examples, okay? All right, let's go to the next box. Okay, so here we're once again defining the axis of symmetry. That's a vertical line. So axis of symmetry is a vertical line that passes through the vertex and divides the parabola in half. And here it's telling us that the axis of symmetry is a vertical line that will have this equation, x equals the opposite of b over 2a. By the way, if that sounds familiar, that's kind of like we have that opposite of b over 2a in the quadratic formula, don't we? Okay, so that's something to keep in mind. The vertex is the lowest point on the parabola if the parabola opens upward. So in our last example, right, our vertex was that origin, that's 0, 0, and it was the lowest point, okay? The vertex will be the highest point on a parabola that opens downward. The vertex will always lie on the axis of symmetry. So the x-coordinate of the vertex, because it lies on that axis of symmetry, is -b over 2a, okay? And then how we find the y-coordinate of the vertex is that we're going to substitute that into the quadratic equation. So you will see in the examples that we first compute the opposite of b over 2a for our x-coordinate, and then we'll substitute that into our function to find the corresponding y value. Okay, so here are the pictures we were just talking about. When a parabola opens upward, you have a vertex is the lowest point, and here's your axis of symmetry that's going to go through the vertex. When the parabola opens downward, the vertex is the highest point, and again, your axis of symmetry goes through the vertex. And how do we tell if a parabola is going to open upward or downward? Well, the leading coefficient a will tell you. So if your leading coefficient a is positive, then your parabola will open upward. And if your leading coefficient of a is negative, then your parabola opens downward. Okay? Intercepts. How do we find intercepts of a parabola? Well, a parabola's intercepts, for the y-intercept, you are going to let x equal 0 and you're going to solve for y. And to find the x-intercepts, you're going to set the equation to 0 and solve for x. Okay? And again, here's your vertex formula, and you'll see us use that in the example. So let's go to the first example. So now in our first example, we're going to take a function in standard form, and we're going to graph the parabola. And how we're going to do that is we're going to look at the function. We're going to use a, the leading coefficient, to determine if the parabola opens upward or downward. Then we're going to find the vertex using the vertex formula. We're going to find the x-intercepts by setting y, or f of x, equal to 0 and solving for x. We're going to find the y-intercepts by setting x to 0 and solving for y. We're going to find one more point on the parabola. And then we're going to also determine the equation of the axis of symmetry that goes through the vertex. And we're going to plot points on the graph. So here's our first equation. We have f of x equals x squared plus 6x plus 8, which is in standard form. So a is 1, b is 6, and c is 8. And given that a is 1 and that's positive, that tells us that this parabola is going to open upward, which means that our vertex is going to be the lowest point on the graph. So let's go ahead and solve for that vertex using the vertex formula. And as we remember, the vertex formula for the x-coordinate is that x is equal to the opposite of b over 2a. So that means that x is equal to the opposite of 6 over 2 times 1, which is negative 6 over 2, or negative 3. So we've just found the x-coordinate of the vertex. And to find the y-coordinate, we're going to substitute and find f of negative 3. So we substitute negative 3 in for x in the equation to solve for the y-coordinate that goes with that x of negative 3. So using my order of operations here, I get 9 minus 18 plus 8, which is negative 1. So that means that our order pair negative 3, negative 1 is the vertex of this parabola. So that's going to be our lowest point, isn't it? As a matter of fact, let's go to the graph and just graph that negative 3, negative 1. So scrolling down, I'm going to go ahead and put negative 3, negative 1 right here on my graph. And I'm going to know that that's my lowest point. So my graph will open upward. And the next thing that I know is that I have a vertical line that goes right through that vertex. So it'll go right through that. I'm drawing it dashed in a different color because it's not part of the parabola, but it is a feature that helps us graph the parabola. And this is called the axis of symmetry. And vertical lines always have equations that say x equals a number. And every single one of the points that's on this red dashed line, right, has an x-coordinate of negative 3. So the equation of this axis of symmetry will be the x equals negative 3 as an equation. So let's go back and fill that in for part B. Axis line of symmetry. And again, I give us a little reminder here. Make sure that you write your answer as an equation and not a single number. So x equals negative 3. Okay, so now we're going to find the x-intercepts of the parabola. So where does the parabola cross the x-axis? And so that means that we need to set f of x, or y, to 0. And we're going to solve for x. So the equation was x squared plus 6x plus 8 equals f of x. Well, we're going to set that to 0. And then we're going to solve this quadratic equation for x, and using one of our many methods, right? Well, this one factor is pretty easy. So let's go ahead and use the factoring method and say x plus 2 times x plus 4 equal to 0. And then we're going to use the 0 factor property, and we're going to set each of these to 0 and solve for x. So we're definitely getting that we're going to have two x-intercepts. One's going to be at x equals -2. The other one's going to be at x equals -4. And the order pairs that go with that is -2, 0. Remember, we set y to 0 to solve for this x. So the y coordinate is 0 and the x is -2. And this second intercept will have order pair -4, again 0 here. So let's graph those on the parabola. So -4, 0 and -2, 0. And notice that they are mirror images of each other across our axis of symmetry, just the way we expected. Okay, let's go find the y-intercept next. So the y-intercept, now we're going to set x to 0 in the equation and solve for y. So we're going to set x equal to 0. So our equation again, so we're really calculating f of 0, aren't we? And our equation was x squared plus 6 times x plus 8. And notice how I've replaced the x with zeros. And so that gives us 8, doesn't it? So 0, 8 is our y-intercept. And if you happen to notice that 8 also happens to be our c value, see, let's check that. See that? C was our 8 is our c. Then you're going to learn pretty quickly that 0c is our y-intercept when you've got your equation in standard form. Okay, we're also, let's graph that. So 0, 8 up here. And again, because we have this mirror image thing, we're going to go on the other side of the axis, and there's going to be a corresponding point right there, which is at -6, 8. Okay, good. All right, let's find one more point, f of -5. So x is -5. What's the y? Let's substitute -5 into our equation so we can find the y coordinate and use our order of operations here. And so looks like we've got 3. So -5, 3 is on our parabola. So let's see if it is, right? Because we've got a good shape going here, don't we? So -5 and up 3 right there. And across the axis, we've got the mirror image at -1, 3. So graphing our parabola now, definitely an upward pointing parabola. Nice symmetry along x equals -3, our axis. You've got your two x-intercepts and you've got your y-intercept. And there's our parabola. Well done.